yt minus 1. Okay, so today's temperature is dependent on yesterday's temperature. Today's stock exchange prices are dependent on yesterday's stock exchange prices. So we can say that this is the reason we have introduced the lag element into the equation. I'll give you another example of this is that, say for example, that at present the vaccine shots are given to the frontline workers, and we assume that these vaccine shots should be working immediately. You should be given the protection or the resistance power should be there with us within 50 days to control this pandemic. But say for example, if this vaccine shots are given and you say that your recovery, your resistance power will start after 15 days, after say for example after 6 months, then people will go crazy that what is happening, how we can do this. So this is the simple example of cross section that the effect is immediate. But that is not the scenario in any time series analysis. For example, a slight change in the monetary policy is not going to have the immediate effect on your money supply. But this will be in some quarters that the effect will be you can see the effect which can be there. So how many quarters we have to go back, that again is a subjective matter. Is a subjective matter in the sense that can be resolved by using some test. This test are known as lag criterion test, for which we are using a method like Schwartz criterion or a Kaike information criterion. So how many legs we have to go back, that we have to determine. So one component is very clear that this is there. Now whatever you try to do, there will be always an error element in an equation, which we saw that thing. Okay, there is always an error element in the equation. Now, is the error independent, or even the error is having something? So I am saying I am introducing the term DET minus 1. Okay, DET minus 1. Then I am saying that DET minus 2. So there is again, the error is also dependent on the past data, and I am trying to introduce the error element. Okay, so this is plus dash dash dash. So now what are these terms? So these terms are, this term is known as please yeah. So this term is known as AR, auto-regressive model. This term is known as AR model. Okay, and this term is known as moving average, MA. Okay, and suppose you try to make the series stationary by using some differentiation techniques. You differentiate it. Then if you do it for the one time, it is known as I1. If you do it for 2 times, it is known as I2. And from that, now it is known as Arima. Okay, Arima, auto-regressive integrated moving average models. Okay, and from that you try to make the equation. If you include another exogenous variable which is having a shock on this, then it is known as Arimax. It is known as Arimax model. If you try to make this equation using neural network, then it is known as Narimax. It is known as Narimax. If the same model is used for the seasonal fluctuation, it is known as Sarima. It is known as Sarima. Okay, so one by one we will try to resolve all these problems in the environment of R. Okay, and why I prefer R over any other software, that also I will try to make you understand. Is there any question? Please ask. Is there any question? Please ask. Any questions? Any questions are there? Please ask. No? Okay.
So what is this Narima?
It is if we are trying to solve the equation of Arima using neural network in MATLAB, then it is known as Narima. known as Narima. We are not going to use that complicated method here right now. We are going to make the life simple at present. We'll be just doing Arima, how we'll be testing that thing, how we'll be using that thing. We'll see that. Okay. So with this basic knowledge of work in R, I hope that you have already started working in R, but still, this is a script window which is there. This is a console window. Okay, this is where the plots are generated, and this is a history window. Okay, anything which you type here, okay, anything which you type here will be generated. The codes will be generated here, right? So with this, just a minute. With this understanding, just okay. So let me try to bring the file ARDL directly into the environment of R. How I can import the file? Import dataset from Excel. Okay, from Excel. Which file I want? That is a very basic file, ARDL file, auto regressive distributed file. It is just a data which I will show you. So I want to fetch this data in the environment of R. F. Okay, F. Research methodology. This is the area, this is the path in which my data is there. I'm just saying data, bring ARDL, open, and import. So data is there. So this is a data of GDP, exports, and consumption. Okay, this data is there. You can see this data. Now I want to work on this data, so I'll say first thing I'll say is attach. To make the command line simple, ARDL attach, control enter, right? Control enter. This is I'm trying to teach you directly from my book, which is there available on Google directly. You can see. I'll show you. It's directly available on Amazon. I'm directly teaching from my book only. The book name is Statistical Analysis Using R. Okay, this book. Uh, this book is coming with the new format. Okay, this new format, this format. Because in this pandemic, this bookseller has got bankrupt, and therefore this is um, uh, national publisher. Okay, my another book which is there with the international publisher is Machine Learning Using R, and it is also you can see in the top list, the first suggested list for reading, first book suggested for reading machine learning using R Rattle. So I'm trying to teach you directly from there only. Right. Now in this I require some libraries. Okay. So these libraries are the packages which can be installed directly, and these packages give you some flexibility. Okay, some flexibility so that you don't have to write the complex command. So one library which is devoted for econometrics is P series library. Okay, just click on P series and you can see library T series, then library LM test. Library LM test is also LM test. Okay, so these libraries are loaded, and now what I want is I want to check the stationary. Okay, the null hypothesis is always there. Is series is non-stationary. Series is non-stationary is always the null hypothesis. Remember, series is non-stationary. There is only one test in which it is said that series is stationary, that I will talk. So what I have to write down is series is non-stationary. Now whatever thing which I write in R using hashtag, it clearly understands that this is not the command line, and therefore it will not generate any error to it. Now I want to do augmented vehicular test using GDP. Okay, using GDP, and GDP not found. Okay, GDP is not found. What is wrong? is wrong. Yeah, attach GDP. Oh, so it is written in caps. So GDP, control enter, and you can see the p value is less than 0.01, and we can say that, okay, we can say that this is stationary, right? P value is smaller than the printed value, right? The printed value. Again, we'll check for consumption. Let's check for consumption. What we are getting for consumption. So ADF test. So I'll write this thing here. ADF test for consumption. P value is less than 0.001, and that's the way you can check the stationarity. Okay. Let's now make the equation. How we will make the equation? Let's try to understand. Model 1 is equal to a linear models. I'm making linear model. No complexity right now. The GDP is equal. This is a sign of field. Is equivalent to expo plus consumption. Okay, consumption. Run. Summary. Model 1, control, enter, and you got the result. Now it is saying that as this p value is more than 0.05, we are in the position to say that exports and consumptions are not export and consumption are not at all affecting the GDP, right? They are not affecting the GDP. Is it clear? So this is very clear cut. Now, after that thing, what we have to do is, so we have to see the behavior of our devil. Okay, the devil which was there. So we'll say plot model 1, and it will give me some plots which are known as which have been kept reserved for residuals. So you can see the first plot which is being generated is residuals versus fitted. As far as possible, this red line should be nearer to this dotted line and should be straight. Okay, but here you can see that there are some observations which are there, and because of which we are not getting the proper graph. Okay. Second, more and more dots, more and more points should be on the dotted line. Then only we can say that the residuals are following the normal distribution. Now, what this normal distribution is, let's try to understand. That I am saying that what is the probability? What is the probability of committing very big positive error? Committing very big positive error. Again, I'll go back to the basics. Okay, what is the probability that the spigonmanometer is saying that your blood pressure is 130, and you are saying no, the blood pressure according to the theoretical is 40. So very big positive error or very big negative error. So the probability of the occurrence of the very strong positive errors should be very less, and the probability of the occurrence of a very strong negative error should be very less. More and more your errors should be towards the mean, and the mean which we have kept reserved for this is 0, and therefore the error should follow the normal distribution. Okay, and as error should follow the normal distribution, if I open this graph and if I draw the quantile plot, it is the same thing. It means that more and more points will be on the dotted line. What do I mean by dotted line? This is the ideal line, and this is the points of our model, the residuals of our model. More and more points will be on this line, right? So let's try to see, is it following? No, it's not following, and therefore there is something wrong in it. This line should be, red line should be straight. Okay, and the Cook's distance, there is one observation 315 which is beyond the dotted line, and therefore we can say that this observation is creating too much problem. 315 is creating too much problem on our data set. So this is a very simple regression which we have done. Now we will try to make the things complex. We'll try to make the things complex by using the Arima modeling techniques. Any questions is there? Please ask. Anybody having a question, please ask. Okay. Are you able to listen? Hello?
Yes. Yes.
Okay. Now I am introducing the Arima model. I assume that there is a effect of some past on my data. So I am importing the new data set from Excel, browse, and the name of the data set is Sensex. So there is we always know that we work on written files, right? So library T series is already there. I require library ggplot to, okay, this is the library for graphics. Now I say plot nifty, control, enter. Oh, object nifty not found. Okay, not to worry. Attach and sex. And you can see what has happened. Now, is it possible to predict this Sensex? Can you all tell me? Is it possible to predict this Sensex? Okay, so we cannot say that thing until and unless we confirm something. The first thing which I want to confirm is Nifty mean 6538. It is not mean returning series. Very clear. The situation is very, you can say, problematic. Standard deviation of the Nifty, how much it is varying? Oh, it is very high. 2473 is very high. Fluctuation is very high. Variance of Nifty, you can see it is lasting series. Now, what to do that if the main thing is if the original series is like this? So let's, this is the reason we work on returns. Plot series, things are looking very much clear, very nice. Mean returns, let's try to check it. Oh, it is nearer to 2.50. It is very nice. Let's check the standard deviation. How is it operating? And therefore, mean return series standard, it is much less. And let's see returns. And therefore, we can say that we can definitely work on this thing. Now, before making Arima model, it is necessary that we should check the series is stationary or not. So the stationarity test is being conducted. Stationarity test. Which tool we will be using? ADM.test on returns. Control enter. P value is less than 0.01. We can say that the series is stationary. We can definitely say that the series is stationary, but we want to make the augmented, that is autocorrelation function, that how it is looking, and just let's try to check it, that is the series stationary in the autocorrelation function. And yes, you can see, you have to ignore the first zero, but you can see all of them are in the blue dotted line, and I can say that the stationarity is present. Exceptionally, one is jumping out of the blue line, but still, if it is getting confirmed by augmented decay fuller, nothing better than that. Nothing better than that. Let's try to check about parcel autocorrelation function using returns, and let's see that thing. So it is also a good thing. Okay. Now, if the series
Sir,
is stationary, nothing.
Excuse me, sir.
Yeah.
Hello. Sir, what
Please.
is the meaning
Yeah.
of returns? What are we getting by returns?
This, madam, see, this is a returns.
Okay,
Previous,
okay.
वो हम करते हैं ना, returns जो करते हैं, today's price minus yesterday's price divided by yesterday's price, that is returns.
Today's
or
price
you
divided
can
by
also,
yesterday's price.
yeah, or you can also take the log of it. You can also take the log of it.
Okay, sir.
Log of the series. Okay.
Okay,
See,
sir. Thank
one thing, if you go by if you go in returns, this thing this concept is very clear that what is happening in returns, right? Just be with me. Suppose there is some price 23, 34, 54, 12, 56. Now what we do in returns, what we are doing it, E2 divided by E1. Huh? Is it clear? So this is
you.
the
Yes,
thing
sir.
which we are getting. Similarly, if I take the log of it, log of E1, okay, and I take the addition of it, okay, the addition of it, and if I take the summation of this, sum of C1 to C5, this, take the summation of this. Is it same? Is it more or less same? Is it same? Why?
Yes,
Because
sir.
what is happening in this process, I will tell, I will explain it. Just a minute. What is happening in this process, I will explain it. Okay. Understand the econometrics in a read good books. Suppose if I say log A divided by B. Okay. What is this log A divided by B? Those who are coming from the mathematics background, it is log A minus log B. Okay. Next way, what I am taking is log C divided by C. What is it? This will be log C minus log B. Third way, log C divided by B.
Sir, log
So
B
here it will be
log B minus C. Na?
So second one will be
log
log B minus
sorry log B minus log C, right, log C, log C minus log B, and when you will take the summation of it, now we are left out with only two terms, and the terms are log A minus log B, which is equal to log A by B. So that's the reason we get the summation from both the sides equal, and that's the reason we work on returns. Another reason for working on returns is that the series gets smooth, and therefore we are using it. Okay. So with this concept, now we are very clear. One thing is very clear. We are very clear that the terminology which we are using is Arima. Okay, in which the first term is kept reserved for AR, autoregressive. Second term is kept reserved for the integrated. Third term is kept reserved for the moving average. But we very well know that the S series is stationary. We will be working on zero only here. This is stationary. We don't require to do any calculations on the integration. Fine. So if this is clear, then we move to Arima. The models are active. We will be working on returns time series. And what is the model which I want to check? So I want to check is 100, right? 100. So this is AR1 model. Okay. Let me try to specify something that is AR1 model. Control, enter, summary, AR1, control, enter. Is the model running? C100 is the model running, or it has generated some error? Arima returns C100. why it is giving such thing. Returns. Okay, so we got the result. Summary function does not work on this. That's fine. It's clear. Now let's try to see that is my this thing significant or not. So the coefficient of AR terms should be nearer to 1. If it is near to 1, it indicates the random walk theory. And the series is not stationary and hence it cannot be predicted. Now here it is 0.0656, which means this is good, which is means good. If it is nearer to 1, it follows the random walk theory and the series cannot be predicted. Okay, so we are having the value here 0.0656. So if I want to make the equation, it is very clear what I'm trying to say is if I want to make the equation, where is the equation? Yes, this is the equation. So this coefficient at present is 0.0656. Okay, it is 0.0656. This is taking the value of 0.0656. But can I say that this model is best? No, I cannot say that thing. So for this, I will have to go for a number of other testing. Now I am saying MA1. Let's see what is the scenario of MA1. Arima returns, comma, C 0, 0, 1, enter, control, enter, MA1, go, enter. Okay, and enter. And now I am having MA1 also, so it is also 0.061. But I am not able to say that which one is better. So just keep on the track of the AIC criterion which is there. Okay, the model which is having the least AIC criterion will be picked up. The model which is having the least AIC criterion will be picked up. Okay, be with me that thing. Okay, be with me that thing. So now I'm saying that now let's start working on AR2. Okay, AR2. So I'm saying Arima returns C2 0 0 control enter AR2 control enter. So now 3930. Okay, MA2. Now I say that why not AR1 MA1. Okay, AR1 MA1 Arima returns C1 0 1 control enter AR1 MA1 control enter. So how many combinations I will go? This is endless. Okay, this is endless. How many combinations I can go?
So what 001 200 how do you get this?
Sorry?
100 001 200 from which source you are getting this model?
I'm not able to understand, sir. क्या कह रहे हैं आप?
Is 100 001 200 from which base you are getting this?
I'm trying to test. Sir, huh? It is a trial and error which I am trying to do. Okay, it is a trial and error which I am to do. But those who are very professional in the sense that if you want to have an experience of this good thing, then please try to read the Arima pattern of the chart. Your question is very appropriate. I really appreciate that thing. That on the basis of Arima chart, you should be able to understand that which Arima can be followed. So just a minute, I'll share something that how you can pick up that thing from the charts. Good question. Very nice. Very good question. That methodology is also known as Box-Jenkin methodology. Okay. Now see. This is the pattern which is seen. If your ACF is having a geometric pattern, and your PACF are having significant till P lags, it is a AR model. If ACF is significant till P lags and PACF is geometric, then it is MA. If both are geometric, then it is ARMA. Let's try to see the example. See this. ACF significant till P lags. This is ACF. ACF is in black and PACF is in white. PACF is geometric. PACF is geometric state. So it's a MA1 process. Okay. Let's try to see another thing. ACF significant till P lags.
Sir, full form of ECF?
Partial autocorrelation function. And PACF is geometric, right? So here MA2 process is there. So there are some people, it's just like X-ray chart, and from X-ray chart also you can say that which one will be valid. Okay, so ACF is geometric, PACF is till P lag. Okay, if you don't want to go in all these details and you want that, please extract something which is, you can say, which is in a palatable format, and I don't want to take too much trouble. Then what I can do? Okay, can anybody tell me what I can do? So there is some function which is known as auto Arima, which is there in library forecast. Okay, library forecast. Control enter auto dot Arima. It has not got active. Just a minute. Just wait for a minute. Okay, let's see auto. Yeah, it is active. Auto Arima returns control enter, and it has directly extracted the best model which is there. Right? The best model which is there. There is one package which is known as library Stargazer, which is also there. Stargazer control enter, which can give you some more power. Okay, more power. Wait a minute, I'll try to make an equation for you. Stargazer ER1 MA1 type equal to Arima modeling control. Just a minute. Before I run that thing, I'll Stargazer control enter. Just a minute. Type is there. Type AR1 MA1. So this is not working, otherwise we could have made the comparison of the models which are there. Anyway, so the best model which is being extracted is auto Arima, this one. So we can say MA1 is considered to be the best model. So when you are able to extract the best model, what now will you do is, next role is that is let's check the diagnostics of this model. Okay, let's check the diagnostics of this model. So we'll make this model as final model. Okay, this model is made as final. Arima returns C 0 0 1 final control enter. The diagnostic checks are residuals. Is my ECG appropriate or not? Yes, diag Arima dot final control enter. Find the function PS tag G and control enter. And you can see the residuals are very nice, ECG is very nice, ACF are inside, PJ values are, everything is appropriate. And when the model is ready, okay, now it is in the stage of prediction. So plot Arima dot final and control enter. There are no dots outside the circle, and that also we can say that it is very nice. It's really nice. So now last part of the day, prediction. Predict. Please predict for next 10, 10 years. What will be the thing? Predict. Arima dot final. How many period you want to predict ahead? N ahead. Number of period you want to predict ahead. 10. Control. Enter. Then enter. Predict. Control. Enter. And you are able to see it has given you the prediction which is there. Okay. It has given you the entire prediction. Frequency 1, time series, start, end. Everything is there in front of you. Right. If you want to say, for example, if there is some series which is not able to give you good, then how will you differentiate? So difference, sense, okay, sorry, it's not something. Okay. I take some another sense spelling is right, difference is also right. What's wrong there? Oh yes, this series is already there as well, therefore it's creating a problem. Difference, six, it's creating a problem. Let me see. Yeah, fine. Okay. The Nifty. Suppose if this series was non-stationary, and I wanted to make it stationary, then how to create a difference? So this can be done by using the Nifty control. Enter. The Nifty has been generated. Okay. Now you see the Nifty how it looks. Then this is the Nifty first difference. I can also insert this thing into my modeling. How? Auto Arima. Okay. Auto Arima D Nifty. Okay. D Nifty. Please work on D Nifty. Control enter. And here also it is giving me MA1 is the best model. So thank you all of you. Let me give you a quick briefing of myself, what I'm doing. Just 2 minutes, not more than that thing. So we have made a teachers training program, and it is not like that we are charging any hefty thing. Whatever your university feels, you can ask to the sir which has invited us. We are not charging any hefty thing, but it's just for a researcher that we have came out with such program. And what are the topics which we teach? Are I'm just sharing with you. There is my WhatsApp group also, in which you can join so that you can get the notifications of all such programs which are being conducted all over the world by me. Right. So this is a teachers training program which has been there, and the softwares which we teach are these are the software: SPSS, TViews, Amos, Gretel, Minitab, MATLAB, Jamovi, R, Design Expert, NVivo, Tora, Gephi, Stata, Python, data science, entire data science. In this, these are the contents like basic data analysis using these are the contents for basic data analysis, correlation, regression, parametric, non-parametric. Once you are clear to this, then I will take you to the next level, that is advanced data analytics using all these softwares, whichever software you want to listen: multiple regression, exploratory, confirmatory, reliability, cluster, conjoint, discriminant, logistic, multi-dimensional scaling, correspondence analysis, survival, one-way ANOVA, two-way ANOVA, repeated merging ANOVA, ANCOVA, MANOVA, MANCOVA, and SPANOVA. Then we give the training for structural equation modeling also using SPSS MOS. This is a very renowned technique. Then we also give the training on basic econometrics using EViews, in which we discuss about multicollinearity, heteroscedasticity, autocorrelation, semi-variable analysis unit to test. In advanced level, we teach them Arima, co-integration, VAR, vacuum, GAR family, entire GAR family, simultaneous equation methods. In advanced level of econometrics, we give the training on panel data.
So what is the procedure for joining this?
The training of machine learning using Orange software, R software, Python, in which we discuss about supervised learning, unsupervised learning. All those who are coming from the engineering background, we give them the training on design of experts using Minitab and design expert software. Those who are coming from medicine.
Sir, how can we join here? How can we join?
Just a minute. Just. This is those who want to be a part of quality management using Minitab, we give them the training. Social network analysis, we give the training on fuzzy logic, data envelope analysis, analytical hierarchical process. Okay, how you can join me? You can join this. Just send me this is my contact number. Just send me hello on this number, and I'll send you the WhatsApp link so that any such program which is there, which is being conducted anywhere in the world, you can be in touch with me and you will get the first notification. Okay, it is not necessary, it is not compulsory that you get registered to me. Fine, it is fine. There are no payments involved, not a single rupee you have to pay anywhere. All these programs which are being conducted anywhere in the country, they will be most of the time free of cost. You don't have to pay anything, and if the fees will be there, it will be somewhere around 600 or 700, not more than that. So thank you all of you, and this is end from my side. Any questions are there, please ask. Over to you, sir. Over to you, sir.